Hi, good evening, everyone. Welcome again to our SPM revision seminar. All right, so for tonight's class, we would be having physics subject, and our tutor for tonight will be Mr. Ilham. So without further ado, I would like to hand over to Mr. Ilham. Mr. Ilham, the floor is yours. Thank you.
All right, thank you, Mr. Azani. All right, hello everyone. Welcome back to our class. Okay, so this is physics class. This is physics SPM revision seminar. Okay, held by Help University. Okay, so this is week 7. So as how we progress this week, we are going to cover chapter 7 in our SPM syllabus. Okay, chapter 7 is electricity. This one is in Form 5, Chapter 2 topics. Okay, so let me share my screen. Okay, so this is our slides for today. Okay, so let me share it fully. All right, so for this week, we are going to cover basic electricity. Okay, we are going to view the basic part of electric circuit. Okay, the main idea for this week is to actually cover the basic part of the electric circuit. So in this week, we are going to be doing cover on what is meant by electric charge. Okay, electric charge, and then electric field, and then from here we are going to try to develop the idea of what is a current, what is potential difference or voltage. Okay, this is also known as voltage. And then we are going to look at resistance. Okay, we have two types of resistance. For resistance, we are usually going to be making them in series or in parallel circuit. All right. Next, after that, we are going to be doing EMF, okay, electromotive force. Okay, and then last but not least, we are going to cover electrical energy, power, and also efficiency. Okay, all right, so let's get started. Okay, so starting is what we need to know is we need to define something called as electric charge. Okay, so what is electric charge? Electric charge is one of the fundamental quantity that exists in our universe. Okay, so this electric charge, this is like some sort of a mass, okay, or length. Okay, those kind of things, they are developed by nature independently. Okay, so somehow nature developed charge the same way as somehow nature developed mass. Okay, so there is a deeper theory in how we actually can obtain this one. This involve fields, but then we are not going to talk about that because our view is only on the SPM level. Okay, so if you want to know more on how we get the fundamental quantity of charge, okay, we need to go deeper into one of the modern theory in physics. Okay, all right, so this idea for you guys, I think it is better for you to just take that electric charge exists. Okay, the same way as how mass exists. Okay, the same way as how length exists. Okay, so electric charge also exists. All right, there are two types of electrical charge. First one is positive charge and second one is negative charge. Okay, so a positive charge is usually the example. Let me get a pen. The example for positive charge is usually we use proton. Okay, proton is one of the example for positive charge particle. And then we also have negative charge. Okay, negative charge is, for example, we have electron. Okay, so this is these two are the main idea, the main example when we are talking about charge. Positive is proton, negative is electron. Okay, and then we can also have object which have zero net charge, meaning that they are not positive, they are not negative, but then they are called as neutral item, neutral object. Okay, all right. Okay, so as mass, okay, mass, when we talk about mass, mass must have a magnitude. Okay, mass must have a number. If we talk about a mass of an object, the mass associated will be, the how big the object is. Okay, the object is 10 kilogram. We say that the object is heavy. 1 kilogram, the object is very light. Okay, so for charge is also the same way. Okay, so one charge is equal to 1.6 times 10 to the power of negative 19 C. Okay, so what is C? C over here, C is the coulomb. Okay, this is called as coulomb. Okay, so coulomb is the unit for electric charge. Okay. All right. So, for example, if you have in your exam, in particular in paper 1, because paper 1 involve calculation. Okay, so example, you were requested to find the sum of charge. Okay, so find the total charge. Okay, given for example this question, find the total charge of 2.5 times 10 to the power of 19 electrons. Okay, so I think you can imagine that you have some sort of very bundle of electrons. You have around 2.5 times 10 to the power of 19 electrons. Okay, so the question is, how many charge does this electron carries? Okay, how many charge does this electron carries? Okay, so in order for you to actually obtain the value, you need to multiply number of electron multiply with the charge itself. Okay, number of particle multiply with the electron charge, which is going to give you the sum. Okay, Q. Okay, so number of electron over here is 2.5 times with 10 to the power of 19. And then for electron charge, this is 1.6 times 10 to the power of negative 19. Okay, all right, so this is the total charge is going to be 4. Okay, if you multiply this, this is going to be 4 coulomb. But then always remember that this is electron. So electron is a negative charge. Make sure you put a negative value. Okay, all right, so this is a tips just in case if you encounter this kind of question. You can change this to a proton. Okay, find the charge of 2.5 times 10 to the power of 19 proton. You can do that. Okay, just multiply number of proton that you have, multiply with 1.6 times 10 to the power of negative 19, and then adjust on the negative or positive. Is it negatively charged or is it positively charged? Okay, all right. Okay, so here is an interesting idea. Okay, we have negatively charged particle, we have a positively charged particle. Okay, but then what happened over here? Okay, when we have a candle flame, okay, this one can come up in your paper 2, I think, or paper 3, I don't know. This one involve experiment. Okay, so we can come up with this experiment where you have a candle. Okay, you set up a candle. Okay, and then you let this candle burn, and then you set up this two plates. Okay, two plates. Okay, these two plates have extra high tension power supply. Okay, and then they will create among themselves, the plate will create some sort of electric field. Okay, so they are going to create some sort of electric field. Okay, let me get a pen. Okay, they are going to create some sort of electric field among themselves. Okay, so negative will go to positive. Okay, so now my question to you guys is, for this kind of situation, you are going to have this flame to actually be moving towards one plate. Okay, it's going to be bended. Okay, a standard flame will look like this. It will go up and then it will go down. But for this case, when you have a plate besides them, okay, it will actually be bended towards one. It is actually going to go only towards one side. Okay, so the question right now is, why does that happen? Okay, so that happen because when you are burning stuff, okay, there will be some sort of ionization occur. Okay, combustion will occur. Combustion. And when combustion occur, then there will be ion transfer. Okay, there will be a transfer of electron. Okay, ion transfer. And when that happens, the candle itself will actually create a positive and electric charge, positive and negative charge. Okay, and then because of the positive and negative charge, they will be attracted to some of the plate. Okay, and then it will actually causes the what you call the flame to actually bend towards one side only. Okay, so the positive will be attracted to the negative will be attracted to the positive. Okay, but because of the size, proton actually have bigger size compared to the electron, so this one is going to be much more bigger. Okay, so the positive is going to be much more bigger compared to the negative ions. Okay, all right, so here's a question: why do candle have iron? Okay, the answer for that is because of the combustion process. Okay, for combustion we have O2, but then when combustion occurs, the chemical reaction is going to cause electron charge to actually be transferred. Okay, so that's how we actually have the ion over here. This is the rough idea for the ion. Okay. All right, so from here, I want you guys to develop this idea of electric field. Okay, so electric field, what is electric field? Okay, electric field is a field that actually permeates space, which surrounds an electric charge. Okay, so electric field, this notation of field, okay, it actually shows that when we have, let's say we have a charge, a positive charge, this positive charge is going to have its very own electric field. Okay, it is going to have its very own electric field. Okay, so if it is positive, the electric field is going to go out. If it is negative, the electric field will go in. Okay. All right, so why do we have this kind of idea? We have this kind of idea because of the characteristic of charge. Okay, so for example, if we have a positive charge and then we have a negative charge, okay, we know that positive charge and negative charge, they are going to be attracted to each other. Okay, we know that positive and negative will be attracted to each other, but we know that there is nothing that interact between them. Okay, they are just attracted to each other. So this cannot really happen in real world. You cannot have two objects attracted to each other without anything in contact whatsoever. Okay, so the idea over here is that we introduce this field concept. Okay, so positive charge, it goes out. Okay, it goes out. And then negative charge, it goes in. The field of negative charge will go inside. And somehow this positive charge, it can actually goes into the negative charge. And that causes this line, they are actually going to combine. Okay, they are not going to go up, it's going to be combined with this line. This line over here, this is actually going to combine with this line. Okay, so the idea for field actually stems from the fact that we cannot really describe how the charge actually transfer between how the charge are actually attracted to each other or they repel to each other. If we don't have field, then it doesn't make any sense. Okay, all right, so we can have a positive charge over here. We can try to describe them. Now this positive charge, it goes out. This one also goes out. This one goes out, this one goes out, the field, electric field goes out, but for this positive charge, this one goes out. Okay, this one also goes out. Now this line and this line, they actually contradict each other. Okay, they cancel each other out. So in a sense, they are going to actually repel each other. Okay, they are going to repel each other. Okay, so because these two lines, okay, this electric field from this charge 1 and this charge 2, so the electric field from charge 1 is going to repel the electric field from charge 2, and that what causes two positive charge or two negative charge with a particle with same charge, they are going to repel each other. Okay, so the key idea over here is the concept of field. Okay, so this field is particularly useful when we want to describe a charge. Okay, all right. So electric field from one charge can exert a force, on all other charge, okay, either by attracting them or repelling them. Okay, so you can see this idea, the idea of field, is actually being used in sci-fi movie, such as I think they also use this one in Star Trek. Okay, if you remember the Jedi, they have the ability to actually use the force. Okay, so this guy over here, he is a Jedi and this is another person. Okay, without any contact, he can actually push this person. Okay, push this person going back. Okay, so how does that actually works? They actually use the same principle as this one. They have some sort of field, okay, existing around us, and by controlling that field, they are managed to actually move the person using causing a force felt by this person using this field idea. Okay, so that one is for Star Wars lah. Okay, for those of you who actually watch Star Wars, you might understand that a little bit better. Okay, all right. So in this picture, if you can see, there is a difference between this one actually just shows the difference. Okay, so over here you can see when you have 2, 4, 6 line over here, this 6 line, they are going pretty separated. So this is actually a weak field. Okay, electric field. This is a weak field. And then for this one, because they are more tightly squeezed, okay, they are much more stronger field. 2, 4, 6. Okay, they are more stronger field. Okay, and field can also be represented like this. This is a standard field. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 line going out from this charge. And then for this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have 18 on this part. Okay, so for this part, this one is much more stronger compared to this one. Okay, so because why is that? Because the field line is much more than this one. Okay, so this one is stronger, this one is weaker. Okay, and this one, this part, this is position. Okay, this is position. Now, when you are near to a charge, the field is going to be much more stronger compared to when you are far from a charge. Okay, you can also imagine this like when you are in the earth. Okay, if let's say this is a negative charge always going in. Okay, so imagine like this is the earth. Okay, if this is the earth, then when you are near the earth's surface, the gravitational pull is going to be very high. But when you are at the atmosphere or you are, at the ISS, the gravitational pull will be weak. Okay, so this is the idea for weak field. Okay, so other than electrical field, we also have gravitational field. Okay, this one is just for additional information. We also have gravitational field. Okay, and this is the idea that I use when I talk about this one. Okay, the gravity just now. Okay. Okay, so just now I mentioned about the charge. Okay, this is a positive charge. Positive charge will always go outwards. This one is a negative charge. Negative charge will always go inward. Okay, so this is positive. This is negative. Okay, now what happened when you have two same charge? Okay, what happened is that they are going to be when you try to actually push them together, they are going to push themselves. Okay, if you want to try to make them hold together, they are going to be separating. Okay, they are going to create a force among themselves. And the same is for negative charge. Okay, this is the imagination line that we have. Okay, so these two are when they actually repel each other. And for this one, you can see this is what happened when positive and negative charge they actually combine. The charge actually combine. Okay, you can see this. The line actually combine just very nicely. Okay, so this is attraction. This is okay, this is a track. This is they are pushing each other. Okay. All right. So other than charge, we can also have electric field being caused by a charge plate. Okay, this is actually a charge plate. Okay, so how do we get a charge plate? It's pretty easy. To get a charge plate, you just need an electrical power source. Okay, and then connect them into a plate. Okay, and then the plate, the electric current will actually move from the plate. Okay, and then it will be charged. Okay, the plate will be charged. Or the easiest one is you can just take a rod, and then you can just have some sort of a cloth or something. You can just rub the cloth to this rod. Okay, this is the rod, this is the cloth. You can rub them together, and the charge is going to be transferred, so they can become this can become a negatively charged. Okay, all right, so once the rod is negatively charged and you put a point charge particle over here, the particle will interact with this rod. Okay, so something like this one, similar like this one. Okay, so this is the pattern that you can expect. Okay, when this is positive, this is negative, so it is going to go from positive to negative also for this part. Okay, and this is a pattern between two plates, so two plate is going to go like this, and this one is the pattern between one charge and also a ring. Okay, it goes out like this, goes in like this. So this one is just for to actually inspire you to be able to imagine this field line. Okay, all right. Okay, next we are going to look at electric current. Okay, so what is electric current? Electric current is the measure of flow of electron. Okay, measure of flow of electron. When we want to define electric current, okay, electric current is the changes in current divided by time. Okay, how fast a current is actually moving over time. Okay, and the unit for a current is ampere. Okay, so this is the idea. You have a power source. This power source supplies the charge. Okay, and then when you complete this circuit, the electron is going to just move. Okay, the current is going to move from here. It goes to the positive. Okay, so here is an example question. If 30 coulomb of electric charge flow past a point in a wire in 2 minutes, okay, what is the current in the wire? Okay, so you can try and do this one. This one is pretty easy. Okay, so you want to find the current in the wire. So the current given is, this is the formula I. You have Q over time. The Q is 30 coulomb. The time is 2 minutes. Okay, so the trick over here is this is in minutes. Always change into standard unit. So 2 minutes times with 60. This is going to be 120 seconds. Okay, so you need to have 120 seconds. Okay, so this is 1, this is 12, this is 1/4 coulomb per second. 1/4 is 0.25, and then this is the ampere. Okay, the unit for current is ampere. So what is the current that was created by this electric charge? Okay, the current created is 0.25 ampere. Okay, all right. Okay, next we have is potential difference. Okay, so potential difference is the difference between 2 points defined as the work done in moving 1 coulomb of positive charge from one point in an electric field to another point. Okay, so for this one, I am going to use the plate just now. This is the idea that you can have to actually view what is potential difference. Okay, so let's assume that this is a point charge particle. This is a positive plate. This is a negative plate. Sorry. This is a negative plate, negative, negative, negative plate. Okay, so now you have a positive charge over here. Positive charge, it is attracted to negative plate, so it need to move from here to here. Okay, so potential difference is what is the difference between what is the work done in order for you to move this 1 coulomb of positive charge from one electric field to another point. Okay, so from here you want to move it to here. Okay, so you want to find the work. Okay, so to find the work that is actually the work done to actually move this object, this charge, that is called as potential difference. Okay, so this is the formula. The potential difference of V, this is equal to work done divided by the amount of charge. Okay, so work done divided by amount of charge. Okay, so this idea over here, I usually tell my students the idea is almost similar to when you have some sort of waterfall. Okay, when you have a waterfall, okay, assume that this is a waterfall. This is a certain height from the ground. This is the height. This is ground. Okay, so water will actually flow downwards. Okay, so why does water flows downward? Because we have gravity. Okay, and in order for us to have this water flowing downwards, we have something called as potential energy. Okay, potential energy. Okay, we have covered potential energy in our previous chapter, MGH. Okay, but then potential difference also exists over here, where there is a potential difference between here, the top over here, and also the bottom. Okay, there is some sort of potential difference. Okay, the same case for this one. There is a potential difference that allows this what you call this charge to actually move from here to here, the same way as how the waterfall moved from here to here. Okay, all right. So here is an sample question that we have. During an occasion of lightning, 200 coulomb of charge was transferred from the cloud to the surface of the earth, and 1.25 times 10 to the power of 10 joule of energy was produced. Okay, so when the charge actually moved, this amount of energy was produced. Find the potential difference between the cloud and the surface of the earth. Okay. Okay, all right. So how do we actually find the charge? Okay, so we use the formula. Potential difference equals to the work done divided by Q. Okay, so what is our potential difference? Our potential difference is unknown. We have the work is 1.25 times 10 to the power of 10. And then we have the amount of charge is 200 coulomb. Okay, amount of charge transferred is 200 coulomb. So divide this value, you are going to get the potential difference between the cloud and the surface of the earth is 6.25 times 10 to the power of 7 volt. Okay, so if you think about it, if you have the surface of the earth and you know the sky, okay, when lightning happens, a huge amount of energy was actually produced. Okay, and there are countries in I don't remember where, they actually harvest this energy. Okay, this lightning energy, they usually call this as lightning energy. They actually harvest them. Okay, I think this is somewhere in Africa. Is it? It is somewhere where they have a lot of thunder. Okay, they have a lot of lightning. So we cannot do this in Malaysia because our lightning is not really that frequent. But in that country, they actually have this idea where they harvest the lightning energy. Okay. Okay, so you can try and check that one out. That one is pretty nice. Okay. Okay, so now we have looked at what is meant by current, I. Now we look at what is meant, we also have looked at what is meant by potential difference, voltage. Now we will look at something called as resistance. Okay, and this relationship between the relationship between current, potential difference, and also resistance. Okay, the three things, they actually have their own relationship. The relationship is called as Ohm's law. Okay, Ohm's law. So how do you get Ohm's law? V is equal to IR. Okay, V is the voltage, the potential difference. I is the current, and R is the resistance. So what is resistance? Resistance is defined as the potential difference divided by the current, or it can also be defined as opposition to current flow. Okay, how much current flow, and then how much it got resisted by the appliances itself, by the circuit itself. Okay, so the unit is ohm. Okay, this is omega, ohm, and there are several things that will actually affect the resistance. Okay, so the first thing that is going to affect resistance of a circuit is the length. Okay, having a short length and having a longer length of wire, the shorter length will have less resistance. Okay, why is that? Because the energy needed for the current, for the charge to actually move from point A to point B is less compared to the longer one. Okay, so the longer wire will have more resistance. Okay, so you might want to take note on this one, because this one is one of the key things that might come up in your paper too. Okay, so we have this is the first situation, length. Okay, other than length, you can also have cross-sectional area. Okay, other than length, you can also have cross-sectional area. Let me erase this. Let me get my pen. Okay, so next one is cross-sectional area. Now, when you have a bigger cross-sectional area, okay, bigger cross-sectional area, this one allows more electron to move. Okay, instead, if you have a small cross-sectional area, this one doesn't allow much electron to move. Okay, so which one should have less resistance? This one have less resistance compared to this one. Okay, this one more, this one less. Okay, and then temperature also can cause issue for our wire, for resistance, of course, because a wire with high temperature is going to have more energy. Okay, a wire, you can imagine the electron inside the wire with 20 degrees Celsius. Okay, this one is going to be in a room temperature, so the motion of the wire will be quite cool. Okay, it is going to move very standard. But if we have something like 36 degrees Celsius, okay, so the electron is going to move much more faster. Okay, it's going to move much more faster because it have more energy, more heat energy. Okay, so this one is going to have less resistance. This one is going to have more resistance. Okay. All right, and then type of material, this one depend on material. Okay, so this one you are going to be depending on how the atomic structure of the material itself. Okay, so you can have a zinc as your wire. You can have aluminum as your wire. Okay, and one of the most stable wire that you can have is a gold wire. Okay, copper wire, gold wire. Okay, all of these have different kind of resistance because they have different molecular structure. Okay, all right. So if question asks you, how can I reduce the resistance inside my circuit? Okay, So choose for if you want to have it in length, okay, choose a shorter length. Okay, you want to have cross-sectional area, choose the bigger cross-sectional area. Okay, and then temperature, choose the if you want to have less resistance, you need to choose less temperature, and then for material you want to try to get the most stable kind of material that you can have. Okay, that is gold. Okay, the reason why gold is actually quite high in price is because currently we have we don't actually use gold to actually make a wire. The best bet that we can have is copper. Okay, because copper is quite cheap, but then copper still can be used quite efficiently. Okay, people used to use gold and also aluminium as wire, but then these two items, their price got increased in the past 50 years, so they start to reduce this in our circuit. There are still gold in our circuit, okay, but I don't really remember it's not really that much compared to copper, because copper is much more cost friendly. Okay. All right, so now we are going to look at the circuit. Okay, so this is a typical circuit setup for an electrical appliances. Okay, we have two types of circuit over here. Okay, so I want you to try and guess which one is which. Okay, so this is actually known as a parallel circuit. Okay, parallel arrangement. Okay, and this one over here, this is a series arrangement. Okay, so the question now is, the reason why I put this picture is that I want to show you how we actually set up a circuit. Okay, so in order for you to set up a circuit, you need to have a power source. In this case, this is the power source, the battery. Okay, and then you have positive and negative charge, positive and negative. Okay, so the current will move, and over here, okay, over here, somehow we actually split this. We actually split this one. Okay, this will go over here, go back. This will go over here, it will go back. Okay, so this is how you actually put a voltmeter. Okay, this is V. V is voltmeter. Okay, this is voltmeter. Okay, so what is the purpose of voltmeter? The purpose of voltmeter is to check the voltage of this particular object. Okay, this particular appliances. Okay, so always remember this. Voltmeter is placed parallel. Okay, why is it placed parallel? Because you want to find the voltage of this object. You want to find the voltage of this object. Okay, but for A, this one is called as ammeter. Okay, ammeter. This one also ammeter. This one also ammeter. So ammeter is placed as a series. Okay, they are placed straight. Okay, so that the current can pass through this ammeter. It passes through this object, pass through ammeter 2, pass through the object, pass through the ammeter 3. Okay, so why do you put ammeter like this? Because you are measuring the current. Okay, current is always going to flow like this. Okay, so in order for us to flow to measure the current, you need to allow the ammeter to measure the current straight like this. Okay, if you measure the current in parallel circuit, okay, this like this one arrangement, okay, over here the current will actually split, so you cannot really have ammeter to be placed in a parallel circuit. Okay, all right, so that's the idea over here. Ammeter is placed series arrangement. Okay, series arrangement. Okay, so here is some exercise for you guys to try. Okay, so we have this is a series circuit. So we have 2 and 4. Okay, so just in case if you guys don't remember how to actually measure the resistance. Okay, so resistance tips. Okay, resistance in series, the total resistance R total is equivalent to R1 plus R2 plus dot 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 dot. Okay, so how many series resistor you have, you can just add them together. In parallel, however, you have 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus dot 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 dot. Okay, so one is series, one is parallel. Okay, so now for this question, you have the voltage, you have the resistance, you want to find the current. Okay, so how do we find the current over here? In order for us to find the current, we need to use Ohm's law. V is equal to IR. Okay, the V is the total voltage over here. Total voltage is 12 volt. Okay, so voltage is 12 volt. And then the resistance, you need to use the total resistance, so R total. How do you get the R total? R total can be obtained when you have 4. Okay, R1 is 4, sorry, R1 is 2, R2 is 4, so 2 plus 4. 6 ohm. Okay, so now you have V, you have R, you want to find I, you can just V over I is equals to the, sorry, V over, this is, okay, this is actually incorrect. V over R. Okay, V over R is equal to I. Okay, our voltage is 12. Our resistance is 6. Okay, so this is I. 12 divided by 6, that's it. That is 2. Okay, 2 ampere. This is I. Okay, and next we have this setup. Okay, this setup is a parallel circuit. Okay, so this parallel circuit, you have this setup. So you can actually reduce this first, find the R total. So to find R total, 1 over R total, 1 over 3 plus 1 over 6. This is going to be 6. This is going to be 3. 6 times 3 is 18. So this is 9 over 18. 1 over R total. 1 over 2, this is 1 over 2, this is 1 over R total. So R total is 2. Okay, so the total here, you can actually redraw this into this one. Okay, this is the ammeter, and then this is a resistor. Okay, this is, okay, so this one is 2 ohm. Okay, this circuit is equivalent to this circuit. Okay, they are actually equivalent. This is 3 volt. Okay, so in order for you to find the current, so again, use the same formula over here. I is equal to V over R. The voltage is 3. The resistor is 2. So 3 divided by 2, that is 1.5 ampere. Okay, so that is how you get the current inside this circuit. Okay, all right. Okay, all right. So now going next to electrical energy. Okay, so I have talked about voltage just now, the potential difference. I have mentioned that potential difference V is given as the energy, the work, divided by the charge. Okay, this is based on the previous slide. Okay, one of the slide in the potential difference. Okay, so in order for us to find the value for electrical energy, we just move this Q up and we will get W is equal to, sorry, this is not P, this is V, okay, sorry. So W is equal to QV. Okay, so work is energy. Work is a form of energy. So when people ask you, how can I calculate the electrical energy, electrical work, we can get electrical work by multiplying the charge and also the voltage. Okay, so that is the idea over there. Okay, so given the potential difference across a bulb is 240 volt, this is the typical bulb in our house, 240 volt. And the current that flows through it is 0.25 ampere. Okay, so you have 0.25 ampere. Find the energy dissipated in the bulb in 30 seconds. Okay, so this is an interesting question. First thing, when you have this kind of question, list down everything that you have. Okay, first you have potential difference, the voltage. Voltage is 240 volt, and then you have current I. I is equal to 0.25 ampere, and then you have the time. Time is equal to 30 seconds. Okay, and you want to find the energy. Energy is also defined as work, so you want to find the work. We know that the work formula is Q multiplied with V, but then Q is not given over here. So how can we find the Q? Okay, so this thing you need to actually remember that current, we define current just now as Q over time. Okay, current is defined as charge over time. So given this current and also time, you can actually find the charge. Okay, just bring this over here. This is just mathematical trick. Okay, so Q is 0.25 ampere multiplied with 30 seconds. Okay, so this value is this is actually 7.5. Okay, this is 7.5, and unit for coulomb is unit for charge is coulomb, 7.5 coulomb. So Q is 7.5. Voltage is 240 voltage. Okay, so multiply 7.5 with 240, you will get the answer. The work done is 1,800 joule. Okay, so this is how you measure the work. Okay, so even though they do not give us the value, you can still play around with the formula. Okay. All right, so this is electrical. The previous one is electrical energy. Now here is electrical power. Okay, electrical power. So electrical power P is defined as the rate of change of energy that's supplied to the circuit. Okay, so the power is usually defined as work over time. Okay, the rate of energy divided by time. Okay, and then we know that work, based on our definition of for work, is QV divided by time. Okay, and now Q divided by T, this is again, I have mentioned this to you, Q over T, this is current. Okay, Q over T is current. So power is equal to current multiplied with voltage. Okay, this is the derivation. This is very simple. Okay, so what is P? P is electrical power, I is the current, and V is the voltage. Okay, so now this one equation, you can actually split it more using Ohm's law. We have Ohm's law, V is equal to IR. Okay, I can expand this V. P is equal to I, V is IR, so IR. I can have P is equal to I squared R. This is one formula that I can get. Or I can also get another formula. P is equal to, instead of substituting V, I substitute I. So I is V over R. Multiply with V. So this is actually V squared over R. Okay, this is another formula that you can use. There are three formula that you can use. P is equal to IV, or you can also use P is equal to I squared R. You can also use P is equal to V squared divided by R. This is the three idea based on only one equation. Okay, so this is a question that we have. An electric iron has heating element of resistance 50 ohm. So this is the resistance 50 ohm. If the operating current flowing through it is 4 ampere, so the current flowing through it is 4 ampere. Calculate the heat energy produced in 2 minutes. So you want to find the heat energy. Heat energy is energy, so energy in 2 minutes. So time is 2 minutes. Okay, always change to seconds. So 2 times 60 is 120 seconds. So how can we answer this? Okay, so we want to find the E, but apparently we can find E if we know the power. We have P is equal to energy over time. We have the time is 120, but we don't have the power. Okay, so first thing that we need to find is we need to find the power first. Now we have the R and we have the I, so you can use one of the equation. I will just use I square R. Okay, so I squared is 4 squared multiplied with R. R is 50. 4 squared is 16 multiplied with 50. This is 800. Okay, this is 800. So the power produced is 800 watt. Okay, this is 800 watt. Unit for power is watt. I forgot to mention over here. Okay, so now you know that this is 800 watt, and then this is electrical energy divided by time. Time is 120 seconds, so you just multiply them. Multiply 120 seconds. You will get electrical energy, and this value over here is 96,000 joule. Okay, so so this is all the calculation that you will need to know, okay, when you have this kind of chapter. Okay, so the question involving circuit, okay, the chapter involving circuit for SPM level is usually going to be only on either this one or this one. Okay, so it's going to be either series or parallel. Okay, so okay, so before we go to a break, where is the question that I want to ask? Okay. Okay, I have several questions that I want to ask you guys, the one that are listening. Okay, so in this picture of electric current, we draw the current going from positive to negative. Okay, we draw from positive to negative. But definition for electric current is the flow of electron. Okay, it is defined as flow of electron. If it is flow of electron, electron is negative charge. Okay, so electron is negative charge. Now, negative charge electron, it should be attracted to a positive plate. Okay, this should make sense to you. Negative need to be attracted to positive. Okay, so electron should actually come up from the negative plate. It goes until positive part. Okay, so over here in this picture, in this diagram, this is actually the current that we used to draw, goes from positive to negative, but this one is actually the electron path. Okay, the path of actual electron is actually inverted to the current. Path of electron is inverted to the current. So actually what happened is that we actually never understand the properties of current, the properties of electron, but we just assume that current move from positive to negative, just like everything else in this universe that we know of. Okay, so if we have something high, it must go from high to low. So a high potential difference must go to from high to low. So we assume that current also behave in the same way. Okay, but apparently after we have learned about electron and its properties, we realize that we actually make a mistake. Okay, and this arrow over here, this is called as the current, electron current. Okay, electron current. This is the correct one. If you are aiming to actually do electrical engineering, you need to know this way. Okay, but if you are just a standard student, you are going to have to use this one. This is called as conventional current. Okay, this is a conventional current. So using which one, where people usually just use positive to negative to represent a current, you know. But I believe that I believe that people should actually know that what they are doing is a mistake, so that they can actually correct the perception. Okay, so when we are talking about current need to move from negative to positive, because the current that is moving is a negatively charged current. So negative need to move from negative terminal up until positive plate, because negative is attracted to the positive. Okay, all right, so that is for current. Okay, so I will be having some break. Okay, we are going to have some tea break. Okay, meanwhile, while we are going for a break, we are going to have some sponsor ads. And while you are watching the ads, do try and answer this question. We have the first question: our house wiring use which circuit to set up? Is it series or is it parallel? Second question: how can we reduce our electrical usage in our house? And the third one: a balloon is being rubbed with a wool. What happened during this process? Okay, so try and think up of the answer for this one. I will see you after the after the after the break, after the commercial break. Okay, this question. Okay, so Mr. Azani, back to you.
Help Center for Micro-Credentials. Why choose micro-credential at Help? They are accessible. They are fast. They are prestigious. They are specialized. And they're global. Call us at 0327 112000 or email us. Or visit our website.
Okay, thank you for the thank you for the sharing by Mr. Azani. All right, so now we are going to go back to our question. Okay, and probably we are going to answer some question that we have just now. Okay, so this is the question that I've given to you. Okay, let me go full screen. Okay, our house wiring use which circuit? Okay, series or parallel? So to answer this, our house actually use parallel circuit. Okay, sorry about that. Why is it not that? Okay, so our house use parallel circuit. Why does our house use parallel circuit? This is because, okay, when you have a parallel circuit, okay, so this is first application appliances, second appliances. Okay, so sorry, this is Okay, so assume that this is a power source. Okay, if you have two parallel circuit, when one is broken, the other one will not be affected. Okay, so the reason why housing wiring usually use a parallel circuit is because we want to actually have only one. Okay, only one. When one is broken, the other can still be used. Okay, so that is the idea for between parallel and also series. If you use series circuit in your house, if one is tripped, okay, the rest is going to be tripped, and that's not good for your house. Okay, so that's why when you have a blueprint of a house, you are going to have different parallel circuits. Okay, the next one we have is how can we reduce our electrical usage? One of the thing that we can use is we can turn off appliances when they are not used, when not in use. Okay, so the reason why this actually is useful is because if your application is turned on, the charge is going to still move. Okay, the charge is still going to move. All right, so if you have your, let's say this is your TV, okay, and then you have a socket. Okay, so what happened is that even if you don't turn it off, the plug, you don't turn it off, the current from the current is still flowing, but it's going to flow in, but it's going to flow to the ground. Okay, so that is called as grounding process. So you don't really want to have even though even though the electronic device is turned off, but then the charge can still move around. Okay, it can still move from the power source to the ground. So you don't want to have that. And also the other one that you can have is use energy saving appliances. Okay, so those are one of the main things. Okay, all right. So next one we have is a balloon is being rubbed with a wool. What happened during this process? What happened is that during this process, you are going to have the electron to be moved. Okay, so you have, oh sorry, this is a balloon. Okay, and then you have a cloth or a wool. So the wool, when you rub with a balloon, okay, the electron is going to jump from one to the other. Okay, so the balloon will be negatively charged and the wool will be positively charged. Okay, so that is what's going to happen. This is called as a static electric. Okay, so let's try and see the question from the audience. Can we have question? Okay, so okay, so I mentioned Star Trek. Is it? Oh, sorry. Okay, it should be Star Wars, not Star Trek. Oh, I mentioned Star Trek. Okay, sorry. Okay. So since only electron can travel, is it possible to reroute the electrons, or in other words, siphon the electrons from a circuit using positively charged magnet? And it will affect the electricity flow. Okay, so this is an interesting question. So when you have a magnet, introducing magnet to a circuit, it will actually involve electromagnetism, and electromagnetism is our subtopic for next week. So we are going to wait until next week to actually answer that question. Okay, all right. So for everyone, okay, so I will meet you again next week. Okay, please. Okay, so please stay safe, stay careful. Okay, so that's all from me for this presentation. Okay, I will give it back to Mr. Azani. Okay, thank you, Mr. Azani.
All right, thank you, Mr. Eilham, for the wonderful session tonight. Okay, so before we end the session, I would like to have a small announcement to make. So for those who are Form 5 students this year or leavers, you may submit your School Achiever Scholarship Award application through our Hub University webpage. So this award may receive either a full or partial scholarship to further your education at Hub University or Hub Academy Program. So for more information, you may log on to our webpage to find out more. All right. So since there is no more other questions, I shall end the session for tonight, and we shall continue tomorrow for English class, which we will be starting at 8 o'clock till 9 p.m. Okay, so thank you very much to all attendees, and we shall see you again tomorrow. Thank you. Good night.
All right. Good night. Thank you.